This lesson is 1-5 Variables and Equations. We have two objectives. The first, identify and solve open sentences. The second, translate verbal sentences into equations. In order to do that, we have some key terms we need to go over. Equation, a mathematical sentence that contains an equal sign. You'll see 4 different equations here, all of them with equal signs. We have addition, multiplication, we have some with variables here. Our second key term is open sentence. And what makes an open sentence is an equation that contains a variable. In this one here, in red, you'll see that x is the variable. That means it's open. It's open to interpretation. We don't know what x is until we solve for it. On this slide, we have 2 more key terms. Solution. A value. Our next 2 key terms. Solution. A value for the variable that makes an equation true. As we saw on the first slide, we had the variable x. We don't know what it is because it's an open sentence. We use some mental math. We say to ourselves, what number plus 7 equals 19? Mental math. We use 12. We check. 12 plus 7 is 19. And that is how we solve. Solving the equation, the process of finding a solution. And that's exactly what we did here in x plus 7 is equal to 19. On this slide, the problem is find the solution of 12 minus 9 equal to 8. We've been given 3 numbers to replace the m with. So these are all what I'm going to place m with. And I'm going to see which one of these numbers makes it true. We always have to start with the first and work our way until we find the solution. So 12 minus, the first number for m will be 2, is equal to 8. Now 12 minus 2 is 10, therefore it's not equal to 8. This is a false statement. So 2 is not a solution. Remember, the answer is whatever we plug in for m. Let's try our next number. Our next number, 12 minus 4, is it equal to 8? Let me do some work here. 12 minus 4 is 8. This is a true statement. Remember, the answer is not 8, it's the number that we plugged in, and in this case, it's 4. So m is equal to 4. We get to stop. We don't have to check 7, because we know that in an equation, 4 is the answer. Now we're asked to do some mental math on these 2 problems. The first one is 5x is equal to 30. So I'm looking for some number times 5 that's equal to 30. Now I know my multiplication tables, and I know that 6 is a good substitute for x. 5 times 6 is 30, and that's equal to 30. So x is equal to 6. Our next problem is a division problem. 72 divided by some number, we'll call it d, is equal to 8. We're going to use mental math. Sometimes you can think of what number can go into 72. Or also you can think, what number times 8 equals 72? Both of these are good methods for mental math. In this case, 72, using my times table, I do believe 9 is equal to 8. That is true. So D is equal to 8. Alright, we have some more key concepts. These are properties of equality, saying that an equation is equal if it's symmetric. Symmetric is if one quantity equals the second quantity, then the second quantity also equals the first. If you look at the example here, if 10 is equal to 4 plus 6, then it sounds to reason that 4 plus 6 is equal to 10. Our next is the transitive property. If one quantity equals a second quantity, and the second quantity equals a third quantity, then the first equals the third. If you look at our example here, we have 3 statements. The first statement is if 3 plus 5 is equal to 8. That's the first statement, and that's true. Our second statement, 8 is equal to 2 times 4. 2 times 4 is equal to 8. Then we can surmise that if both statements are equal to 8, then we can take these 2 quantities, 3 plus 5 and 2 times 4, and make them equal to each other. That is the transitive property. Let's put what we just learned in the previous slide on properties into some use. Name the property of equality shown by each statement. Problem A, if 5 is equal to x plus 2. To help me out, I'm going to make 5, change it to A, just so we can see it better, is equal to x plus 2. We'll call that whole statement x plus 2 B. Then I'll look at the next statement, x plus 2. That was our B. That's first now. And then it's equal to 5. That's my A. I notice that A is equal to B. B is equal to A. That reminds me of switching the order here, and that is the symmetric property. And the symmetric property I am going to abbreviate. All right, problem B. If y plus 8 is equal to 15, and like I did in the previous problem, I'm going to break it into segments here. Y plus 8, I'll label that A, is equal to 15. I'll label that B. So that's our first statement, simplified. Our second statement, B, since we've already seen it, I'll label that B again. 7 plus 8, well, we haven't seen that yet, so I'll label that C. So we have A is equal to B, B is equal to C. In our third statement, we have y plus 8, and y plus 8 has already been labeled A, and is equal to 7 plus 8. And we really label that C. So we have two statements here. Both of them are equal to B. We drop the B, and we're left with A and C. Since they're both equal to B, we can assume that they're both equal to each other. And that is, ladies and gentlemen, the transitive property. Another good way to remember this is that there's three statements. You can see 1, 2, and 3. That's a good sign that you have the transitive property. And once again, I abbreviated, and there's your answer. On this slide, the problem is the difference of a number and 10 is 17. Find the number. Well, in order to find the number or solve, we need to translate this sentence here. The first is, I know that the difference is subtraction. Then I have a number. Since it doesn't tell me the number, I'm going to use a variable to represent it. 10 is my next number. Is another sign for equal. 17. Alright, the question is, where do I put the subtraction sign or the difference? And what's going to help me is this word and. Since and is in between a number and 10, I'm going to place the subtraction sign. That's what the and tells me to do. Alright, now I have a statement or an equation. N minus 10 is equal to 17. I can do some mental math and say to myself, what number minus 10 equals to 17? I'm going to try 27. Alright, now that I plugged in 27, 27 minus 10, 17. And yes, that's equal to 17. So, the solution is n is equal to 17.